Hello friend, I am Rajesh Singh Chauhan, working as Assistant Professor in B.Sc Group of College in Department of Physics and Science. Today we are discuss about one digital device, decoder and encoder. Today we are talking about digital decoder. How can define what is the definition of the decoder, which is the very important. First we go for the name. The name is showing the decoder. Decoder means decode something, decode the inputs data and give to output as per electronic device. So in simple we define that decoder. Decoder is a combinational circuit which is as like the multiplexer, but in the multiplexer we have the data input, but in the decoder we don't have the any data inputs. That's why we say this is similar to demultiplexer, but this is different by the input data. It means it is have the lines, input lines, which is don't have the input data lines. So in the demultiplexer we have the data input lines and selector lines. So we say this is similar to the demultiplexer. So this is the digital decoder. In another words, we are also say that decoder is a reverse processing of encoding. It means give the information in encoding forms. So this is a reverse of the encoding is called the decoders. It means some data has comes in encoding forms, decoders do in decode forms. So that's why this is the simple definition. It means we have the data input, we have the data lines which has comes or give to multiple output lines. That's why this is called to decoder. Decoder are used so many areas in digital electronics. We just go for the basic digital decoder. Here just go for the basic binary decoder. What is the basic binary decoder? It means first we know about the what is the basic knowledge, basic step of the decoders. Which is very simple. Decoder is nothing. Decoder is not a big device, but decoder is the like the AND gate. Here we get the data line in 4 A, B, C and D. These are the data lines. So we say this is the LSB and this is the M.Sc. Least significant bit, most significant bit. They are lines, these data go in AND gate. So here we get AND operation. So we get the output in the Y form. So this is the decoding. So we say this is the decoding. With 3 lines, 4 lines has come and get output in Y forms. In Y's, 1 line. So we simply define that this is the basic decoder. Now we are go for the type of digital decoder. There is a number of type of digital decoder are available in the market, but as per we go for some example, there is 3 to 8 decoder. This is the basic decoder or first type of the decoder, and number 2 4 to 16 decoder is the 2 types. Number 3rd dual 2 to 4 decoder. It means this decoder have 2 to 4 with dual form. It means we say 4 to 8 decoder. Dual is here. It means 2 to 4 is the one decoder, but we have the dual form. So we simply say there are the data lines 2 and 2. It means 4 data lines, and output 4 to 4. It means output 8 data lines, 8 lines. So that's why we say to 4 to 8 decoder. And another one is the BCD to decimal decoder, which is the very important BCD to decimal decoder, because this type of the decoder are used in binary number, how can change in the decimal number. That's why this is very important. We simply using the decoder we can go or convert the number from binary to decimal. That's why this is important. BCD to decimal. It means binary number can be converted into directly decimal. That's why we are using this one. And now final 5 number BCD to 7 segment decoder, which is also very most important, and this is a very popular in the market, because we are using the BCD to 7 segment decoder. Segment means we have the group of the 7 LEDs which are give the numbers as per BCD inputs. Means which type of the inputs is given, so decoder is reflect the give the data, give the output as per input. So that's why we say this is the 7 segment decoder. 7 segment, 7 type of the LEDs which are blinking as per input BCD. Like the we give the number 001, so it means this is reflect on the 001. So there is 3 LEDs 001, so we represent the 1 numbers in the form of the binary. So BCD to 7 segment, it means BCD number is directly converted into decimal number. That's why we are using the 7 segment decoders. We just also study for detail in the. Now we go for the designing part of 3 to 8 decoder. In any decoder we are using 3 terms. First is the block diagram of any decoder and truth table of decoder, final logic circuit of the decoder. Just we go for the block diagram of the decoder, which is the very important. Block diagram is given the idea of the designing of any decoder. It means how many lines we have in input side, how many lines we have in output side. That's why the block diagram is the very important. So we just go for the 3 to 8 decoder. As per the word, we just go for that. Here 3 to 8 decoder. It means we have the 3 input lines in the form of the A, B and C. In the and output side we have the 8 lines which is start from the 0 to 7. So that's why we define this line. So we say to 3 to 8 decoder, which is the very important. So now what is the value of the Y0? It is very clear. Y0, the input lines have 0, 0, 0. That's why we say to this is the Y0. And Y1, this is the number of the 001. It means number 1. Then Y2 means this is represent the digital number is 2 and binary number is the 0, 1, 0. This is a binary number. So these value has come as per binary numbers. And now we just go for the truth table of the 3 to 8 decoder. We just go for there. Here these are the binary inputs data, binary inputs line. So here 0, 0, it means we select the line of the Y0. That's why Y0 is showing the 1. So that's why we go for here Y0. A bar, B bar or C bar. It means 0, 0 or 0. That's why we are here show the 1. It means Y0 line is selected. In another part, we just go for the Y1. You just looking in the side of input lines here 0, 0, 1. It means number 1. So here 0, 0. It's A bar, B bar, C is the 1. So we say the 1 is the very clear. So line Y1 is selected and go on as so on. In the last and final we go for the here Y7. Y7, how can value has the come in the Y7? Y7, if we are select the Y7, just showing the 1. And then here go in the input line. So input line here 1, 1 and 1. These are the input data. Input data has come from there. So we are select the line number Y7. Now, we just go for the logic circuit of 3 to 8 decoder. It means designing part of the 3 to 8 decoder. How can design? This is a very simple. We just here 3 input line A, B and C. We just go, this is the invert of the A, invert of the B and invert of the C. It means we have the 1 and 0, 1 and 0, 1 and 0. It means have the A and A bar, B and B bar, C and C bar. So simply we just go here Y0, we require the Y0. What is the Y0? In the, we just go for in truth table, here Y0 is showing is equal to Y0 is A bar, B bar and C bar. It means we give the data, we connect the lines from A bar, B bar and C bar. This is the first output line of Y0. And another Y1. Y1 here A bar, B bar and C only. It means we have take the line from A bar, B bar and only C. So this is the Y1. And another Y2 is also very important. So here what is the value of the Y2? A bar, B dot, C bar. Here we get the line from A bar, B and C bar. These are the Y2 and so on. Finally we just go for the Y7. Here Y7 in the truth table, Y7 is equal to A, B and C. It means we get the line from the A here, B here, C here. Directly we connect with the AND gate because this is the AND operation, dot dot dot, it's AND operation. So we get the Y7, A dot B dot C. This is the Y operation. Now we are talking about the 4 to 16 decoder. We have take the 3 steps in any decoder designing. First is the block diagram. So we are using the block diagram of 4 to 16 decoder. Number 2, truth table of the 4 to 16 decoder. Just go for there. Here this is the data lines, input lines, or this is the output lines. We just give the 4 input lines. It means 4 showing the 4 and 16 means output lines. So here the 16 output line because we are showing the from Y0 to Y15. It means 0 is also including. So that's why this is the number of the 16. Here truth table is here. There is the digital input 0, 1, 2, 3. So we just convert in binary form. So binary number has as per comes as our output lines. So Y1 here we select the Y0 because Y0 is the A bar, B bar, C bar or D bar. So that's why A bar, B bar, C bar and D bar. These are in the input side. That's why we just show the 1 in the output side. It means we select the line of the Y0 and another here just go for the Y1. We are using the same procedure for that. So here A bar, B bar, C bar or D. We are not give the bar on the D. It means we are using the number 1. So and so on. We all step are go for there and finally we go to Y15. Y15 is the A, B, C or D. It means there is no bar. So simply the last number is 1, 1, 1 is the final value. Now we are talking about dual 2 to 4 decoder. This is a very simple. We just go for 3 step of in any digital decoder. We here first block diagram of dual 2 to 4 decoder. Here dual means we have the 2 of decoder in one circuit. That's why we say to dual decoder. First is the decoder first and second one decoder second. DMAX. We say to DMAX or decoder. So this is the DMAX first and this is the DMAX second. Here input line is 2 input lines and another one is the enable. It means enable is the working condition or not working condition. And this is the number 2 inputs. So here 2 inputs is the second. So that's why this is the first decoder, second. That's why we are say to dual decoders. So we get the output line here 4 from the one decoder and 4 from the another decoder. So total output has come from 4 plus 4, it's 8. So that's why we say dual 2 to 4 decoder, or we simply say 4 to 8 decoders. This is the in dual form. Now we are talking about the BCD to 7 segment decoder. First we go for the block diagram of BCD to 7 segment. This is very simple. We are using BCD input in A, B, C, D data lines, input lines, and then these are the output lines. We are connected with the 7 segment LED. These are the A, B, C, D are the LED which are just showing the digital number. Which number is given in the binary form in the input and we get the output in decimal as form of the LED. So LED which LED is glow. It means number which given by the binary in the input and LED is the glow. So these are showing the digital number, decimal number of that. So first we go for the, if we give the input in input line in 0 0, so it means we get the decimal number of 0. It means 0 means these outer LED are glows. It means A glow, B, C, D, E or F, but G is not glow. So we just off the G. So all are the on. So this create the number of decimal 0. Another, we just give the input of 0 0 1. It means we give the number of 1. So this is showing the decimal number 1. How can create the decimal number 1 in the LED, 7 segment LED? It means we glow the LED B and C. All B, G, D, E, F are the off. So that's we create the number of digital 1. So it's simple, we are using that. B or C are on and another all LEDs are goes to off. Then create the number of 1. Another one is 2. We give the number of decimal 2. So LEDs glows are 2. So here we create in 7 segment as 2. Here 2 is this. So A on, B on, G on, E on or D on. It means F or C is the off. So we just go for that. Here F or C is the off in the 2, right? So F or C is the off for the 2, and then we go for the number 3. It means we got the 0 0. So this is the number 3. We create the 3. He's here. It means F or E is the off for the number 3. F and E is the 0. Another is the on. That's why we create the number of 3 in LED. Number 4. If we give the binary number in the 4, so we create the 4 in decimal number. How can create the in the 7 segment as the LED? So in the 4, here F, G, B is the on, another is off. It means A off, E off or D off. So that is the procedure where we create the 7 segment as per input BCD. It means we directly input binary number convert in the decimal. This is a fantastic example of the decoder or use of the decoder. We say the use of the decoder. We just give the binary numbers in input side, we got the finally output of the. Okay. Now we just go for the reverse of the decoder. Reverse of the decoder is called the encoder. Encoder is here and input data lines and we got the M output lines, which is the working as per formula of 2 raised to power n is equal to M. It means we give to n information in data lines, we get the number of output. We gives to 2 raised to power 2, it means 2 data lines are the input. So we get form of 4 outputs. So this is the encoder. Encoder is the reverse process of the decoder. That's why we are using this is the encoder. Thank you.